What's up guys, welcome back to the channel. In this particular video I will explain the problem perfect numbers. This problem is quite easy guys, but you will definitely learn something new in this particular video. So let me start with the problem statement. It says that you are given a number n. You have to check if a number is perfect or not. What is a perfect number? So a number is said to be perfect if the sum of all its factors excluding the number itself is equal to the number again, right? And you have to return 1 if the number is perfect, otherwise return 0. So guys, one example is given here. First of all, what are the factors? Factors are those numbers which completely divide a given number, right? Let me explain what are the factors for the number 6. So I have a number 6. Simply write the number from 1 to 6. I have 1, 2, 3, 4, 5, 6. Now, among all these numbers, what are the numbers that completely divide 6? I have 1, then I have 2, then I have 3, or then I have 6, right? Now guys, see, it says that sum of all factors excluding the number itself. So I can simply exclude the number. And then what is the sum of all factors? I have 1 plus 2 plus 3, right? This is nothing but 6. You can see that the sum of the factors of the given number is equal to the number itself. So this number is a perfect number. So the output is going to be 1, right? Now guys, I hope you are clear with the problem statement. So let's talk about the solution now. Okay, so I have written one example here guys, and I will use this particular example in order to explain the approach. See, after looking at the problem guys, as the problem is easy and very straightforward, so the first approach that will come to your mind is we can start a loop from I equals to 1, then I is smaller than n, then I plus plus, right? And even you can see that for number from like 1 2 3 4 5 6, all we need to do is we need to check if a number uh, I divides completely divides the number n, right? Only in that particular case the number I will be the factor of the number n, right? So I will simply check if my n uh, okay, I'm representing with small n. Let me write capital N here. If my n mod I is equal to 0, in that case I have got a factor, right? And I have to make a variable sum. This is initially equal to 0, and I'll say that okay, sum plus equals to I, right? This is what I will do. At last, once this loop is completed, I have got the sum of factors. So I'll simply do one thing. If my sum is equal to n, in that particular case, this is a perfect number, right? So I'll simply return 1. Else, else return 0. Let me write here, return 0. So guys, this is the first approach that we have. And interestingly, we can optimize this particular approach as well, right? I will definitely show you. See, first of all, guys, this is the approach that we have, and the time complexity of this particular approach is O of n. This is the time complexity, and space complexity is surely O of 1, right? Because we are not using any extra space here. This is about the first approach. We can optimize this. Let me show you the optimal approach that we have. So first of all, let me erase everything that I have written here. Guys, I hope you have noted this particular approach down, right? Okay, so let me remove this. And I want you to notice very interesting fact about factors. Even I guess I have already explained in one of my previous videos, right? So let me explain it again, guys. See, okay, let me erase this particular thing as well. I'm writing numbers from 1 to 6, right? And then I'm checking if a number completely divide n, so that I can determine whether it's a factor of 6 or not. So 1 2 3 4 5 6. Now see guys, 1 divide 6, 1 completely divides 6, and then what is the quotient that when we divide 6 by 1, 6 divided by 1 is nothing but equal to 6, right? So in that particular case, in this form, I can simply say that 1 is a factor, right? Because 1 can completely divide, and you can see that I'm getting an integer here. This is the proof that 1 is completely dividing number 6, right? So this particular thing, can I write like 6 by 6 equal to 1? Right? And you can see that if I compare this particular form with this particular form, so now I can say that 6 is a factor, right? Because 6 completely divides like 6 completely divides 6, right? So and the quotient is 1, which is a complete integer, so I can say that 6 is a factor of 6 itself, right? After this, let me write one more thing. I know 2 is a factor, so what I'll do is I'll simply divide 6 by 2, right? And what is the quotient that I will get? I will get 3. So in this particular form, guys, I can say that 2 is a factor because 2 is completely dividing 6, right? And we are getting 3. Now, can I write the same thing as 6 by 3 equals to 2? Again, you can see that if 3 is completely dividing 2, so can I say that 3 is a factor of 6? Because you can see that I'm getting a like integer number, right? We are not getting any number in point or decimals. Like in we are not getting any decimal form here, right? So this is a complete integer form. This means that 3 is again a factor of like I. This means that whenever we have I as the factor of n, then n divided by I is also a factor of n, right? So once I have got that I is factor of n, so I can simply determine n by I is also factor. So I don't need to check it again, right? So this means that if I start a loop from 1 to like 2, then I can get the sum. Why? Because I don't need to check now this 3. I will simply do one thing. Let me erase this, guys. Let me erase this. This is really going to be interesting, right? See, I will simply do one thing, that if if n the mod I equals to 0, this means that I is a factor, right? So I'll simply do one thing, sum plus equals to I plus n by I. And you can see that now I'm covering uh, two factors in just one step, right? And even, guys, if I take a greater example, let's say I have an example 16, or I have okay, let me take another example. So let's say we have 18, right? So let me write the number from 1 to 18. I have 1 2 3 4 5 6 7 8 9 10, then 11 12 13 14 15 16 17 and 18, right? These are the numbers from 1 to 18. Now you can see that 1 is a factor of 18, and if 1 is a factor, then n by I, like 18, will also be a factor, right? After this, you can see that 2 is a factor of 18. If 2 is a factor, then 9 will definitely be a factor, right? Because you can see that if I is a factor, then n by I is again a factor. I have already proved this particular thing mathematically. After this, 3 is again a factor. If 3 is a factor, then 6 will be a factor, right? Because 6 into 3 equals to 18. After this, we don't have any factors, right? So this is how we can get the sum, guys. But if I take another example, let's say, let me explain this, guys. Let's say if I take an example which is 9, right? If I take an example which is 9, so for 9 I want to show you something. This is very important observation. I have 1 2 3 4 5 6 7 8 9. Guys, this video may take some time, but it will definitely you will learn something new here, right? So make sure you stay tuned till the end of the video. See, 1 and 9 are going to be a factor of 9, right? After this, I have 3 and 3 again, right? So see, when I see that 3 is of something which is a factor of 9, so I will do 3 and I will do n by I, right? 3 again. My question is, why I am adding 3 and 3 again? This is something that we face in case of only perfect squares, right? If I have 16, then I will add 4 and 4. So I have to handle this particular case as well. I have to make sure that I add every number only one time, not two times here, like we are doing. So I will simply erase this and I will handle this particular condition, right? So I'll say that, okay, now I have to check one more condition, like if let me change the color, guys. So if my n divided by I is not equal to I, right? Only in that particular case I will do this particular thing, else I will add only one time. So I'll say that, okay, now sum plus equals to I. So guys, this is something that you need to take care of. So now I guess this main idea is clear to you. So we are simply going to write the code based on this particular idea. See, I will say that, okay, for I equals to 0, then okay, I'll not do I equals to 0, guys. I will start with see, if I write for example 6, okay, if I take an example, let's say 1 2 3 4 5 6. So this is example for n equals to 6. So if I start from 1, then I will add 6 again because of this particular condition, right? But I have to avoid 6. So what I'll do is, in order to avoid this particular thing, I will initialize my sum with 1 so that 1 is included, and then I'll start with 2. So this way we can avoid this particular 6. So I'll say that, okay, for I equals to 2, then I is smaller than, what is this condition, guys? And then I plus plus. When I have to stop, this is the question, when I have to stop. So I have already explained you for the example 9, right? you can see one thing. Okay, even I can explain with this particular thing as well, guys. See, I have I here, I have n by I here, right? As I increases, n by I decreases. So I will stop at the point where I becomes like greater than n by I, isn't it, guys? Or I becomes, or I square becomes greater than n, or I becomes greater than square root of n, right? This is our this is the condition that we have, but we have to include equal as well. Like if I have 9 as the example, so 3 into 3, this is something that I also need to include, right? So I will write a condition. This is the point where I have to stop. So where I am going to run, I will run till my I is smaller than equal to square root of n, right? This is something that I need to do, guys. And after this, I can simply write this particular condition inside this loop. Once you have written that particular condition, so it is something like n mod I equals to 0. Then what I'll do is I'll simply check if n by I is not equal to I. This is the main thing. Then I'll do sum plus equals to I plus n by I. After this, the second thing is else sum plus equals to I. Guys, this is something that we need to do. At last, we can again check if sum is something which is equal to n, then return 1, else return 0, right? Return 0. This is something that I can do. And once we have done this, our task is done. Time complexity is O of root n here, which is very much optimized now, right? Guys, this is all about this particular problem. Now I just need to show you the code, right? So what I'll do is let me show you the code. This is the Java and Python code, guys, and let me show you the C++ code as well. This is the C++ code. You can see that code is very similar to the what I have explained in the video, right? And this is about the Java code, and this is the Python code. Now, guys, this is all about this video. I hope you have understood everything. Thank you.